In this presentation we're going to look at graph theory, and in particular we're going to have a look at paths and cycles. This is part of my Discrete Maths series of presentations. So here's the question. We have a graph here, G, and I have the adjacency matrix up here, or the adjacency list, and what I'm first asked to do is write out the degree sequence of this. So we have a vertex here, and it is connected, vertex 1 is connected to vertex 2, vertex 3, and vertex 4. It has a degree of 3. This vertex here is connected to 4 other vertices, so it has degree sequence, or degree 4, 3, 3, and 1. So list the degree sequence of this here. So we'd actually write it in descending order. So we'd start with 4 first. 4, 3, 3, 3, and 1. The next thing we have to do is draw the graph. So what I'm going to do here is in the top right, I'm going to start off by drawing the vertex with the highest degree, which is vertex 2. I'm going to connect it to vertex, all the other vertices here. Now I have sort of a fair idea what it looks like, so I'm just drawing it out in a particular way. So I'm going to draw that here first, and I'm going to connect these two together. So this is how we might draw it here. I'm just going to color in the vertices, blue, and there we go. No, one more. We're going to have to connect these two here. So if just look at this now. So first off, we have in the middle, we have degree vertex 2 over here, and this is connected to vertex 1, vertex 3, and vertex 4, and also vertex 5. So let's look at this now. So I have vertex 1 here. It is connected to vertex 2, vertex 3, and vertex 4. Vertex 2 is connected to all 4 of them, all 4 of the other vertices, V1, V2, V3, V4. Vertex 3 is connected to V1, V3, and V4. V1, V2, and V4. And likewise, vertex 4 is connected to V1, V3, and V2. And V5 on its own is connected to vertex 2 there only. So it has degree 1 and it is connected to vertex 2 only. Now it takes a little bit of trial and error. So the best thing to do when you're drawing these is actually to first off try and start with the vertex with the highest degree, and then work downwards, or work in the look at the vertices of the next highest degree, which would be these ones here, and at the end work with the vertex with the lowest degree. Work in that particular order there. Now, so what we're going to draw now is find two distinct paths of length 3 starting at V3 and ending at V4. This is the main part of the presentation. So let's look at that now. So find the two distinct paths of length 3 starting at V3 and ending at V4. So if it is of length 3, it must pass through 3 edges. So let's have an example of one here. A path from V3 to V4, like that, has only of length 1. It only uses one edge. For example, if we were to go through V1, like this, go up there first, and then come down here, that will only have length of 2. So what we have to do is find 2 different ways of a path of length 3. So what we might do first off is go from V3, our starting position, and go down to V2, then go up to V1, and then go from V1 to V4. So that's one of our paths. So that's one path that is allowable. Let's go and find another path. And I'll use blue this time. Well, what I could do first off is go from V3 to V1, then then go from V1 to V2, and then from V2 to V4. So that's another possible path of length 3. So we have in the second case, V3 to V1 to V2 to V4. The first case was V3 to V2 to V1 to V4. Okay, so that's two distinct paths of length 3, starting at V3 and ending at V4. Now what we're going to do is find a cycle of length 4 in G. Well, the difference between a cycle and a path is that a cycle has to start and end at the same place. A path can end at two distinct vertices, where a cycle must start and end at the same place. So we have plenty of options here. So essentially we have to use 4 edges in our path. So I'm going to start with V1. So let's go down here to V4 first. That's 1 edge used. V2. Okay. Now I could go from V2 back to V1, but that wouldn't give us a cycle of length 4. So what I'm going to do is go instead to V3 and then go to V1, and that gives us a cycle of length 4. Now I arbitrarily picked V1 as a starting point, but if I picked any other of those vertices used, I would have got the same answer. Now I can only use an edge once, so that's why I can't use V5. If I was to go from V2 to V5, I just get stuck down at V5. I wouldn't be able to come back. A cycle should only use an edge once. And that ends our presentation.